Hi, this is Professor Fernandez, and this is video 1B in lesson 22. You might want to take a look at video 1A in this lesson 22, the video that precedes this one, because there I talk about trigonometric functions, and specifically I review the interpretations of the midline, the period, the angular frequency, and also the amplitude for sine and cosine. So we're going to need that in this example. This is not quite an example from Calculus Simplified, but it uses and piggybacks off of those concepts covered in Appendix B in the book. Okay, so what's going on here? So we have three graphs that were given of trigonometric functions, and we're asked to find an equation for these graphs, assuming that there are no phase shifts. You may have heard about this term or may not, right? In the previous video, again, video 22.1a, we talked about the standard form of an equation for sine or cosine, right? They both have these standard forms. And we talked about C being the midline, B being the angular frequency, and then we talked about how to find the period from there, and the absolute value of A being the amplitude. Okay, so what does a phase shift mean? Well, there are other generalizations, right? The most immediately useful one is when you have a plus D over here, plus C. So depending on how you define things, most authors, I think, call this plus D the phase shift, or this D value the phase shift. Some authors factor out the B and then call that remaining number the phase shift. I think I've seen that less commonly so. Okay, so this prompt that we're given tells us that there's no phase shift, tells us that we don't have to worry about that complication. In other words, the sine and cosine graphs that you see come from one of these two versions of the equation for sine and cosine. So we need to identify the amplitude, the B value, and the C value. So that is going to help us then write down the equations corresponding to these graphs, which of course means we need to know how to pick out what the A, B, and C values are and what they mean. So again, check out the previous video if you're interested in learning more about those details. So let's take a look at the first example. I'm going to zoom in a little bit here. The first thing I'll say is that if you're trying to pick out a sine or cosine graph, how do you start? Knowing that there are no phase shifts means that you can pick them out, whether it's sine or cosine, depending on where they start. So the run-of-the-mill sine graph, right, starts between its maximum values. So here's a maximum value, between its max and minimum, I should say. Here's the maximum value, here's the minimum value. This one at x equals 0 starts between that max and min. So this is a sine graph. Okay, over here you can see that this graph starts at its maximum value, then decreases to the min, goes back to the maximum. This is a cosine graph. Why do I say all this? Well, go back to the basic equation, for example, for sine here, and look at what happens if we now think of this as a function, f of x. Look at what happens if I look at x equals 0. I would get a times sine of b times 0 plus c. That's a sine of 0 plus c. Sine of 0 is 0, so that's just c. So in other words, at x equals 0, right, the y value, f of 0, of this graph is equal to c. C is the midline. And the midline is, as we talked about in the previous video, the y value that cuts the graph in half vertically. That means that the maximum is above the graph, above the midline. The minimum is below the midline. So again, here's the maximum. It's above the midline, which is 0 here. We'll see in a minute. And then here's the minimum below the midline. So this is, again, a sine graph. Cosine is different. So if we play the same game here, if we say f of x equals a cosine of bx plus c, and I look at f of 0, that's a cosine of b times 0 plus c. That leaves me with a cosine of 0 plus c. Now cosine of 0 is 1, so that's a plus c. So you can see that f of 0, the y value at x equals 0, is a plus c. If a is positive, that means that we are at the maximum value of the graph. If a is negative, we are at the minimum value of the graph. Explains again why this is a cosine graph. It starts at x equals 0 at the maximum value. Okay, and then what about this graph on the right? Well, here's the max, here's the min, and at x equals 0, we are starting in between the max and the min. So that tells us that this is a sine graph. So zooming out here, we now know that each of these has a particular character, if you will. The first and last are sine graphs, and the middle one is a cosine graph. Great, we've made progress. So how do we figure out the a, b, and c values? Okay, so now let's write here y equals a sine of bx plus c, and let's start figuring things out. I find that the first, what I'm about to say is not a rule, right? You can figure out these parameters in whatever order you like, but I find it's useful to look at the midline first, because you can see clearly in this graph that, let me choose the right color here, y equals 0 cuts the graph in half vertically, right? So the whole extent of the graph is from -3 to 3, and y equals 0 is certainly in the middle of that. The c value here, that information tells us that the c value here is 0. Next thing I like to look at is the amplitude. So if I start at y equals 0, how far above do I have to go to get to the maximum y value? The answer is 3, right? This is the maximum. That tells me the amplitude. Okay, so I'm thinking that absolute value of a is 3. Remember, the absolute value of a is the amplitude. Does that imply that a equals 3? Well, maybe or maybe not. If a is positive, it does. But if a is negative, then it would be -3, because its absolute value is also 3. So how do I decide between -3 or 3? Well, so that is a question about what the graph looks like, where it heads off when it starts at 0. This is the graph of sine of x, y equals sine of x. Starts at 0, goes up to more positive y values, as opposed to the graph of negative sine x, which is this one, y equals negative sine x, negative sine x. So this one starts at 0 and goes down to negative y values, okay? So this part of the graph then is telling us what the a value we should choose is. It's telling us that it should be a equals 3, because the graph starts at x equals 0 and goes off to positive y values. Okay, so that tells us that our a value is 3. So now we pin down 2 of the 3 parameters we need. So a equals 3 over here. I'm going to box that in blue. Awesome. And then now we just need to figure out the b. Remember from the previous video that b was the angular frequency, right? How many cycles there are in an interval of length 2 pi. Okay, so we're told here that this is 4 pi, which means that this one is 2 pi. And how many cycles are there in an interval of length 2 pi then? There is literally half of a cycle, right? This is a whole cycle, and this is half of a cycle. So half of a cycle in an interval of length 2 pi, so b equals 1/2. That's the easiest way to figure out what b is. What's another way we could have done this? Well, another way is to use the cousin of b, if you will, which is the period. Remember that the period t is 2 pi divided by b, and the period measures how long, in terms of the x-axis length, it takes for one full cycle. So if I start here, I have to wait all the way until 4 pi to get a full cycle done. So t is 4 pi for this graph, which would tell me from this formula, if I solve for b, which is 2 pi over t, that I have a b value of 2 pi over 4 pi, which is 1/2, same one we got. So either way you do it, whether you look at the period first, one full cycle, period 4 pi, therefore do the calculation, b is 1/2, or you say, you know what, this is 2 pi, we've only gotten half the cycle, so b is 1/2. Either way, b is 1/2. All right, so we have all the information we need for this graph. We can finally write down its equation. It is 3 sine of 1/2 x plus 0. So I won't write that down. So that's the equation that generates this graph. Obviously, you can check your work if you have access to desmos.com. You can graph it there. It's a really nice grapher that I like, or Wolfram Alpha, or a graphing calculator. Or you could just plot points, right? You could try that and kind of make sure that you are on the right track. Okay, so let's move on over here. This is a cosine graph, like we said, and we have a cosine of bx plus c, our standard form. So let's think here, same procedural run through. We see again that y equals 0 appears to cut the graph in half vertically. So half of it is above, half of it is below. So I'm going to say y equals 0 again. Go back and look at the amplitude one more time. So if I start at y equals 0, I have to go up by 4, and I have to go down by 4. Okay, so my amplitude is 4. So absolute value of a is 4. Same question then, does a equal 4 or does a equal negative 4? How would I know? Same answer as before. Here is your run-of-the-mill cosine graph, right? This is y equals cosine of x. Positive. What if I graphed y equals negative cosine of x? Well, it kind of flips this graph about the y-axis. So I would start down here, and then I would go up, and then go down this way to 2 pi. So same idea. So the positive cosine graph starts at the maximum, decreases. The negative cosine graph starts at the minimum, increases. For this graph, we're starting at the maximum, and we're decreasing, so that's the behavior of a positive cosine graph. So we conclude that a equals 4. Okay, so we have our a value, we have our c value, and now let's take a look at the b value. How do we find that? Same as before, we look at the cycles in an interval of length 2 pi. Notice here that pi is all we're given, right? And presumably these are trig functions, which are repeating forever. So if I take this cycle, which is one full cycle, right? I only get to pi, and then I draw it again, another full cycle. Over here, then this x-axis would be another pi, that would be 2 pi. And that's our clue. I have one cycle, 2 cycles in an interval of length 2 pi, so b equals 2 cycles. Again, we could look at this by looking at the period. This is one full cycle right here. It took pi units, so 2 pi over b, b is 2 pi over t. One full cycle took pi units, that's the period. 2 pi over pi gives us the same 2 for b that we just got over here. Okay, so conclusion, b equals 2, after all those different ways you could do it. So we have found a, we found b, we found c, so let's write down the equation of this graph. A cosine of bx plus c. C is 0, so I'll leave it off. So once again, that's the equation of this graph, and we could double check that. We could graph this function, make sure that on this interval, we get this graph. All right, the last one to do here. Let's figure this one out. I'll erase the remnants from the earlier one. So this is similar structure, a equals sine bx plus c. The midline here is not 0, right? Because I'm looking for, notice that this graph goes from 0 to 6. It starts literally halfway. This is 1, this is 2, this is 3. And that is the y value that cuts the graph in half vertically. Half of it's above here, half of it's below down there. Okay, so that tells me that the midline is 3. So in this graph, c equals 3. And then if I start at the midline and I go all the way up to the maximum, I have to go 3 units, 6 minus 3. So the amplitude is 3. Positive 3 for a or negative 3 for a, how do I decide? Remember what we talked about over here in this original graph for sine, right? We already determined earlier that this was a sine graph. The positive sine graph starts at its midline and goes higher. That's what's happening here. So a equals 3 in this example. And then the b value, how do I determine that? Same as before. Let's look along the x-axis now. This one goes all the way up to 9 pi. So let's start here doing it with the period first. I have one full oscillation that takes 9 pi units in the x direction. That's the period. So if I use my b equals 2 pi over t, I would do 2 pi over 9 pi, and that gives me 2/9. That's my b value. So if I'm going to write down my equation then for this graph, it's y equals 3 sine of 2/9 x plus the c value, plus 3. And that's the equation for this graph. And once again, we'll double check. Encourage you to do that by graphing it somewhere and just verifying that graph over the interval from 0 to 9 pi and x looks just like that. Okay, zooming out a little bit, a few quick things to just recap and review. First thing you want to do if you're doing a problem like this and trying to match a graph or figure out the equation for a trig function graph. We've only done sine and cosine here, but still, you want to look at the general features of the graph. Where does the graph start? Does it start and then go up? Does it start and then go down? Does it start at a maximum? Does it start, if we would have been given this, does it start at a minimum? So graphs that you're told have no phase shifts, right? Then you're in good territory, because you look at where the graph starts for the trig function. And if it's a sine or cosine graph, the sine graphs will start midway between the max and min values. The cosine graphs will start either at the max or at the min. And that tells you sine or cosine. And then you run through all of the checks that we just did for extracting A, B, and C from the graph. And like I said earlier, there's no rule for this, but I like to look at the midline first and then extract from that the amplitude, and then extract from that, looking at the x-axis, either the period or the b value, whichever one makes most sense for that particular graph. Great, thanks for watching.